Hello everyone. In today's session, we are going to discuss how to find out the transpose of a given matrix. We are going to discuss two methods by which you can find out the transpose of a given matrix. After that, we will see the program. After completing the program, then we go for the concept of an important topic in C, that is strings. So first, let us have the discussion on how to find out the transpose of a given matrix. We will see how to find out the transpose of a matrix. For example, we have given an array integer a of 10, 10, right? And we have read the elements into this two-dimensional array, and the matrix form of this two-dimensional array is looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the matrix form. So we have read the elements into two-dimensional array A, and we have printed these elements in matrix form. After printing the elements in matrix form, the first element 1 is indicated as A of 0, 0, right? So this is 0, 0 and this is 0, 1. I'm not writing A of 0, 1, just I'm writing 0, 1. Actually, it is read as A of 0, 1. And this is 0, 2. And this is 1, 0. And this is 1, 1. And this is 1, 2. This is 2, 0, 2, 1, and 2, 2. How many rows are there? 3 rows and 3 columns. We call it as R1 into C1. So the transpose of this matrix can be given as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the transpose, right? Now, it is also a 3 by 3 matrix. Why? Because the original matrix is having the equal number of rows and columns. The transpose is also having the equal number of rows and columns. Now, here, see, the row here has become a column, second row has become the second column, and third row has become the third column. This is the transpose, right? So, here we are printing 1, that means we are printing A of 0, 0. Okay, next 4. 4 means we are printing 1, 0. 7. 7 means we are printing 2, 0. Next, the second row, 2. What is the index of 2? 2 means 0, 1. 5. How much? 1, 1. 8. How much? 2, 1. And 3. 3. What is the index? 0, 2. 6. 1, 2. 9. How much? 2, 2. Right? We are printing the rows in column wise, so that we are calling it as the transpose. So, how to write the code for this? See here, the code simply for this is given as, just you write for I equals to 0 and I is less than, rows becomes columns, columns becomes rows, right? Here you write first column C1 I plus plus. Next you have to say for j equals to 0 and j is less than R1 j plus plus. Okay. Now, but here what you do is you say printf percentage d. If you want to get some space, we write slash t double quotes close comma. Here you say a of ji. You have to write a of ji. That's all. So if you trace this code, what happened? I equals to 0, right? 0 is less than C1. C1 how much? 3. 0 is less than 3. Yes, the condition is true. Then go to the second for loop. J equals to 0. J is less than R1. 3. Yes, the condition is true. We are printing A of j value 0. J value how much? 0. And here I value is 0. A of 0, 0. So we are printing A of 0, 0. Here A of 0, 0 is 1. Here also we are printing 1. After semicolon, next we are moving to j plus plus. J value becomes 1. Now 1 is less than 3. Yes, the condition is true. When the condition is true, the printf statement is executed. Here we are saying A of j value how much? 1. A of 1, 0. We are printing A of 1, 0. So here what is A of 1, 0? Here 4. So here we are printing A of 1, 0. 4 is printed. Next semicolon, again move back to j plus plus. J value becomes 2. 2 is less than 3. Yes. 2 is less than 3. The condition is true. Now we are printing again A of 2, 0. A of 2, 0. Here we are printing A of 2, 0. Here A of 2, 0 is how much? 7. Here we are printing 7. Right. Next again we are moving back to j plus plus. j value becomes 3, 3 is less than 3. No, the condition is false. When the condition is false, we are moving to upper for loop. Okay, first for loop, here I is incremented by 1. Again, the condition is tested, 1 is less than 3. Yes, again we are moving back to the second for and j equals to 0. And next we are going to print the second one, 2, 5, 8, 3, 6, 9. This is a simple logic. Okay, this is a simple logic to find out the transpose of a matrix. So in this method, what we are doing, just we are rearranging the elements of j. Okay, and we are printing in what are rows into columns and columns into row. But you can use another method. In the second method, what you want to do, you can take a extra matrix like a, not only a, you take another temporary matrix b of 10 10, and you store the column values into rows we are changing, right? You have to store this a of ji in b of ij. You have to store a of ji in b of ij, and we are going to print the elements b separately. Okay, so in the first method, just we are rearranging the elements of a and we are printing it as a of ji. So that is the first method. In the second method, we are taking the temporary array b, and in the b we are storing a of ji, and finally we are going to print the elements of b. So that is the logic, two logics, so that we can find out the transpose of a matrix. So we will see the program for this. Now we will see how to implement the program to find the transpose of a given matrix. Let us go to the Visual Studio Code, go to new file. Here you write trans.c. Okay, now you write program to find the transpose, of a given matrix. Right, so here we write hash include stdio.h, right, stdio.h. Now you write int main. Firstly, you can write the program. You take the array, two-dimensional array, integer 10. Okay, next you write another 10, 10. Okay, after this you write integer I comma j. Okay, now you say the order, that is we call it as r1 comma c1. Right, now you say printf in double quotes, enter the order, we can say, right, slash n double quotes close. You write scanf %d double quotes close comma ampersand r1 comma ampersand c1. Right, now you say printf, enter the elements you say. Okay, now you say for I equals to 0, I is less than r1, I plus plus. Right, next you say for j equals to 0 and j is less than c1, j plus plus. Right, you say scanf %d double quotes close ampersand a of ij. Right, now after this, now you have to say printf the matrix a is, right, I'm printing in matrix form. How to print the matrix form? Just you copy the elements, control C, and you say here control V. Okay, now you do one thing here, you write opening brace. Right, next you do one, delete it. Now you write here printf %d slash t, right, slash t, we call it as backslash, and you remove ampersand. Right, after this you write printf slash n. Right, this is about how to print the elements in matrix form. Okay, matrix A is. Now after this, what you have to do? Just you have to say printf. Here I am writing transpose is slash n. Right, now I'm printing the elements just in reverse order. Control C, and you write control V. Here just you change rows into columns, columns into rows, and here you write R1. And here you say, don't say ij, here you say ji. Just now I have explained the code, right? Ji. That's all. And finally you write return 0, closing brace, main program completed, right? This is a simple program to find the transpose of a given matrix. We will see any errors are there. Okay, now run it. Wait for the output. It is asking enter the order. You give order 3, 3. Enter the elements. How many elements? 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See here, it is not ending. There is some error maybe in reading these elements. Enter the order. Scanner percentage d. Enter the I equals to 0, I less than R1, I plus plus. Scanner percentage d. 3, 3, 3, 3 means 9 elements we have to read. So why it's not stopping? We will see. Enter the order of the matrix. Scanf R1 C1. Enter the elements. I equals to 0. I is less than R1. I plus plus for j equals to 0. Sorry, here I have not written j. I have printed a. That is the logic. J. I have missed j. Right now you save it. See, small mistakes will do many things. Okay, wait. Now we are going to run it. Now I'm going to run it here. You will see. So it is asking enter the order. Now you enter 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements I have given, but it is giving different output. We will check it. What is the problem here? Segmentation fault. Okay. That we will see what is the segmentation fault. Integer percentage d ampersand a of ij. Okay. R1 j equals 0. Here I have done another mistake here. Here again I have written I only, right? It is j. J is less than C1, right? Here again I have written j, right? Okay. I have some, now after this you save it. You save it. Now you run it again. Now it is asking the order 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, we got the output. The elements we have given 9. So first row 1, 2, 3, second row 4, 5, 6, 7, 8, 9. Transpose you see 1, 4, 7, 2, 5, 8, 3, 6, 9. We got the output. So this is the way of finding the transpose of a given matrix. So why we have got errors? Why? Because in place of j I have typed I by mistake. So that is a mistake we have done, right? So this is one logic to find out the transpose of a matrix. So what is another method? So another method is, this is simple method, but I'm going to do modifications only within this. Another method here is you can take B of another matrix, temporary matrix like this, 10, 10. Okay, here I'm writing 10, 10. Another matrix B of 10, 10, right? So in this case, what I'm going to do is, I'm going to store the elements in the temporary array. See, we are calculating, see here we are calculating the transpose here, right? So instead of directly printing the transpose here, what I'm going to do is, see here, actually here I'm making it as comment. Opening brace and closing brace is also not required, but here what I'm going to do is, here I'm going to say b of I j, b of I j equals to a of ji. I'm writing like this, p of I j equals to a of ji. Just I'm storing like this, okay, semicolon. B of I j equals to a of ji. Okay, after saying this, no need of writing the printf slash n here. Okay, now I'm going to delete this. There is only one statement in this for loop. Then no need to write this opening brace also. Okay, here you can remove this. The changes what we have done is after the second for loop there is only one statement we are writing, that is b of ij equals to a of ji. That's all. So only one statement is there. So that's why no need of writing opening brace and closing brace for the second for. Okay, we are storing columns as rows and rows as columns in the b of ij. Okay, now after this, what we are going to do is after storing the elements in b of ij, now what we are going to do is we are going to print the matrix B. Okay, how I'm going to copy this, and here I'm going to change this as the matrix transpose is B, and we are printing B. Okay, so while printing B, R1 this becomes R1 becomes C1, right? Here it is becomes R1. Okay, now while printing, just I'm saying B of ij. Why? Because already we have stored the elements in reverse order, A of ji into B of ij. Okay, this is another method. Now save it. Now compile whether there are any errors. It is asking enter the order. 3, 3 we set. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, same answer we got. Same answer we got. Okay, this is another method. You can use any method. Okay, so I think no need of explaining everything. Already I have explained theoretically. So here, see, first inner loop is executed. When the inner loop becomes false, it goes to outer loop for I. Again, it starts from. So here the elements are stored, and finally we are printing in matrix form. So these are the ways to find out the transpose of a given matrix, right? So we will see strings, introduction of strings next. Now we will see the concept of strings. Strings are very, very important in C. So we will discuss briefly what the strings are. So let us have the discussion about the strings. C, in the previous classes, we discussed about the one-dimensional array and two-dimensional array and three-dimensional arrays we have already completed. Now, before moving on to how to declare strings, first let us define what a string is. What is the definition? See, we can give multiple definitions for the string. The first definition is it is an array of characters. An array of characters. This is one first definition. And second one, we can say a sequence of characters. A sequence of characters. We can give any definition. And third one is we can say collection of characters. Collection of characters. Or the last one, we can say a group of characters. Group of characters. We can say a collection of characters, a group of characters, a sequence of characters, or an array of characters. Right? See, strings, or we call it as string constants. String constants. Strings are also known as string constants, or we call it as string literals. String literals. A string constant or string literal or a string is an array of characters that is terminated by a null character. This is very, very important. What is the name of this character? Null character. Right? And as we discussed in the earlier classes, the string constants are enclosed in double quotes. A string constant is the collection of 0 or more characters which are enclosed in double quotes. That is, if you write here double quotes, what happened? This is empty, right? For example, if you write double quotes like this, here we have empty space. This is empty space. This is also a string. Here it is 0 characters. This is 1 character. Now, for example, if you write ABC, I am enclosing in double quotes 3 characters, right? We can write 1, 2, 3 double quotes. So it is not numeric. It is treated as string. Why? Because whatever that is enclosed in double quotes are known as strings, or we call it as stringleters. See, whenever we write a string constant in double quotes, automatically its representation could be like this. For example, if you take ABC, it is stored as ABC, and each character is enclosed in single quotes, right? And finally, every string is terminated with the null character /0, backward /0. Don't confuse this /0 with 0. 0 is different. Now, when the characters are enclosed in single quotes, those are known as the character constants. And these character constants, which are enclosed in single quotes, are going to take ASCII values. ASCII in the sense American Standard Code for Information Interchange. So, every character constants are going to have their own ASCII values. That means American Standard Code for Information Interchange. Information interchange. So ASCII, ASCII, American Standard Code for Information Interchange. Why we need this? Why? Because I said that the machine knows only the machine language. That means everything in the memory is represented, or everything is processed in terms of zeros and ones. Okay, zeros and ones. So whenever we give a character, this character is also represented as a number. So when the character is represented like this, small a in single quotes, let's take its ASCII value 97. So lowercase letter a takes the ASCII value 97. Now internally this decimal value 97 is converted into zeros and ones. So every character is represented in the form of numbers, and those numbers automatically converted into zeros and ones. So that is the logic. If you take small b, what is the value? 98. Similarly, if you take the capital A, its ASCII value is 65, capital B 66. Likewise, 0 is also having its own ASCII value, that is 48, whereas /0 is a null character which is having the ASCII value 0. Very, very important. What is the ASCII value of null character? 0. So when we store the string, like when we write the string ABC in double quotes, it is stored as A, B, C, and last one null character in single quotes. So here, whenever we are storing in single character, these are known as character constants. And here, instead of writing single quotes in A, it represents, what is this? 97, and this is 98, this is 99, and last one is 0. When it encounters 0, it indicates that the string has terminated, or it indicates the end of the string, right? So what I mean to say that a string can be represented, or a string can be defined as an array of characters which are terminated by a null character, or we can say sequence of characters, right? How to represent a string? So a string can be represented by a character array, character one-dimensional array. Character one-dimensional array means we are going to talk about one-dimensional arrays of type character. So mainly the strings can be represented. How to represent the string? The syntax for this can be written as, so here we write the character data type. Character data type, here we give any name, or we call it as string name, and here we are going to mention the dimension. So this is the representation of, the normal syntax for representing a string. For example, if you take character S1 of 10, so here the character array S1 is going to contain how many memory locations? 10 locations. Okay, 10 locations, starting with, we know this is S1 of 0, and second one is S1 of 1, and finally we are going to discuss it as S1 of 9. So 10 memory locations are reserved. Okay. Now, for example, after the declaration, if you write a definition like S1 of 10 equals to hello in double quotes, if I say hello, what happened? It is stored like this, HELLO, Okay, everything is internally stored in single character. Okay, now finally automatically null character is inserted. The remaining also filled with null characters, all the empty spaces. This is the internal representation when we assign hello to character of S1 of 10. This is the representation. So now in how many ways we can implement or we can represent a string? There are four methods by which we can represent a string. The first method we are going to talk about, I'm writing like this, character S1 of, here whenever you give the dimension or the size, you give the size which is one character more than the string we are going to enter. Why? Because if you want to give hello, hello consists of 5 characters, but you have to give the dimension as 6 characters. Why? Because we need an extra room or space to store the null character, which is automatically inserted by the compiler. So S1 of 10, if you give maximum more size, no problem, but you have to have at least one character more. Character S1 of 10 equals to, here I'm writing hello. This is one method. And second method is, we can also say character S1 of, no need of mentioning the size here. The size here left side depends on the right side string constant that we are going to assign. Okay, this is the second method. And third one, see, when we are enclosing in double quotes, the null character is not necessary. It is automatically inserted by the compiler to indicate the end of the string. Now, third method, we write it as S1 of 10. Here you can give like this. In this notation, we can write H single quotes, E in single quotes, L in single quotes, another L in single quotes. Last, we are writing the null character. So another fourth method here, same thing. Here, no need of mentioning the size here, dimension. Just I'm writing in single quotes. H E L L and null character. This is the way of representing the strings. How many ways? 4 ways. So this is a simple introduction about the string. So more details we will discuss in the next class. So with this, I'm going to close the session. Thank you for watching.